Dear students, we have seen in a previous class that if there is a change in the price of an input, then the firm alter its input mix. So if there is a change in the W by R ratio resulting from a change in W or R, K by L also changes. So in order to see how the cost curve shifts when input prices change, we must consider the substitution possibilities between inputs. We have shown that cost is a function of output, also a function of input prices, technology also. And technology and input prices are shift factors in the cost function that we have discussed in detail in a previous session. So it follows that whenever there is a change in W or R, cost curves will shift. But how much shift will occur? To see this, we have to study the extent of substitution between capital and labor. And to study the effect of a change in factor price ratio on input mix, economists developed an alternative measure of the elasticity of substitution, an alternative formula, one which is different from what we have considered earlier. In the previous class, we have defined sigma as percentage change in K by L ratio divided by percentage change in MRTS. And elasticity of substitution determines the curvature of the isochord. Now our concern is how input mix will change when there is a change in the factor price ratio when output is held constant. That is, we wish to examine the change in K by L resulting from a change in W by R. Change in K by L resulting from a change in W by R along an isochord. So we use a different elasticity of substitution. S is equal to dou K by L by K by L divided by dou W by R divided by W by R in percentage or in proportional terms. That is equal to dou ln K by L by dou ln W by R. And remember this, specified in this form, this elasticity of substitution measures proportionate change in K by L resulting from proportionate change in W by R. When W by R changes and K by L cannot be altered, its impact on cost will be different from its impact when there will be possibility of substitution between K by L. Also, if we consider two inputs, the exact possibilities we will consider later. This quantity S is non-negative. Non-negative because if there is an increase in the relative factor prices, there will be an increase in K by L also. That is, if W increases relative to R, K increases relative to R and vice versa. So, an increase in W by R is followed by an increase in K by L. So, S is always non-negative. The second characteristic is large value of S means if S is very large, it means whenever there is a change in the factor price ratio, firms will be able to significantly change the input mix or significantly change the input proportions. Low values indicate that change in the factor combination is low when there is considerable change in the factor price ratio. Now, if there are only two inputs, elasticity of substitution defined earlier, that is defined earlier means dou K by L divided by K by L all divided by dou MRTS by MRTS. This was sigma defined in an earlier class. So if there are only two inputs, elasticity of substitution given by this definition is same as this because in equilibrium MRTS is equal to W by R. So dou W by R by dou by W by R will be in the denominator because in equilibrium MRTS is equal to W by R. Stated differently, cost minimization requires that firm equates MRTS with W by R. And the main advantage of sigma, the main advantage of this definition is that it is easier to generalize to many inputs than the definition based on the production function. The major advantage of sigma, this definition is that it is easier to generalize it to many inputs than it is based on the production function. Specifically, suppose that we have inputs x1, x2, etc. xn with the prices w1, w2, etc. wn, then sigma s ij between any two inputs is equal to dou xi by xj divided by xi by xj all divided by dou wi by wj divided by wi by w. So instead of defining in terms of this production function, if we define this in terms of this dou K by L divided by W by R, this definition is applicable in many input cases also. Now, given this definition of the elasticity of substitution, let us consider the quantitative size of a shift in cost curves. We give a quantitative size of the shift in cost curves associated with the change in input prices. And we have shown that if there is an increase in an input price, it will cause an increase in total, average and marginal costs. And now we are in a position to see by how much total, marginal and average cost will increase if there is a change in input price. First one, increase in cost will be influenced importantly by the relative significance of that input in the production process. That is, the impact on cost depends on the relative importance of that input in the production process. For example, if an input constitutes a large fraction of total costs, and if there is an increase in the price of that input, then cost will increase considerably. Cost will increase considerably. If that input is a minor input, and if the price of that input increases, its impact on cost will be very little. For example, if there is an increase in wage rates, and if wage cost is an important cost associated with the building, new constructions, etc., then the cost of construction will increase significantly. That is one. So if, for example, labor is a significant factor, and if there is a significant increase in wage, then the total cost curve will shift considerably upwards. That is one observation about quantitative size. It depends on the relative size of that input. The second, less obvious determinant is the increase, less obvious determinant of cost increase is input substitutability. The point is, if a firm can easily substitute one input for another input, then the impact of an increase in the input price will have little impact on total cost. For example, if the cost of labor increases and the substitution between capital and labor is very easy, firm will substitute capital for labor, the cheap factor, so that increase in total cost will not be very much. On the other hand, if substitution is difficult, whenever there is an increase in the cost of one input, and if the cheap input cannot be substituted for the costly input, the impact on cost will be very high. An example given in the book is in the 1960s, there was a sharp increase in the price of copper. So it was substituted by cheap aluminium cables for the distribution of electricity. As you can see nowadays, electricity transition is taking through aluminium cables rather than copper. So there was no considerable increase in the cost of transmitting electricity, even though there was a considerable increase in the price of copper. The third is, what is the effect of technical change? We know that technical improvements allow a firm to produce the same level of output with less costs. So technical improvements shifts the total cost goes downwards. And a proof is given for convenience. I ignore that. My general statement is technical improvement generally reduces costs. Now, before concluding this session, let me consider an example. And let us see how the cost curve shifts in the Cobb-Douglas production function, where C RWQ was written as Q raised to 1 by alpha plus beta B, are alpha by alpha plus beta and W beta by alpha plus beta, where B, a constant, was alpha plus beta raised to into alpha raised to minus alpha by alpha plus beta, beta raised to minus beta by alpha plus beta. Let us assume that alpha plus beta is equal to 1 and also that alpha is equal to beta is equal to 0.5. Then this cost function RWQ becomes 2Q R raised to 0.5 W raised to 0.5. You substitute the values, you will get 2Q 2 into Q into R raised to 0.5 W raised to 0.5. If you assume that R is equal to 3, W is equal to 12, then C 3 12Q is equal to 2Q root 36 is equal to 12Q. And for Q is equal to 40, C is equal to 480. Average cost is C by Q is equal to 12. Marginal cost is dou C by dou Q equal to 12. And this is the case of constant returns to scale where AC is equal to MC. If any of the input prices change, you complete the calculations, it is very easy. Then suppose that W increases to 27 from 12, that is 125% increase. Then C 327Q is equal to 2Q into root 81 is equal to 18Q, and AC is equal to 18, MC is equal to 18. And increase in age by 125% raises cost by 50%. Raises cost by 50%. 12Q becomes 18Q, cost by 50%. And this happens because labor represents 50% of all costs. And also, labor cost increases by 125%, but cost increases by only 50% because labor represents only 50% of all the costs, and also firm substitutes labor for capital. So this is an example of quantitative shift in the cost curves in the Cobb-Douglas production function, which we have derived earlier. So remember, cost function, shift in the cost function, properties of cost function, and quantitative size of the shifts and factors determining these shifts. One is the elasticity of substitution, the other one is the possibility of, the importance of that input in the production process.